So as promised, here is me going through the addition and subtraction of your radicals. So as I mentioned, you always want to have identical radicals or exponents, otherwise you can't add or subtract them. So if we look at the first row here, the cube root of 11, those are identical. 11 to the 1/4, those are completely identical. 2z, the square root of 2z, completely identical. X to the 7/2, identical. So as long as those are all the same, you're just going to simply add or subtract your coefficients. So this would be 12 cube root of 11 as your answer. This one would be 12, 11, to the 1/4. And you're going to write your answer back the same way they give it to you. 11 minus 5 would be 6 square root of 2z. And then 3x to the 7/2 minus 5x to the 7/2 is negative 2x to the 7/2. Okay, and this is where he's saying if it's not reduced and they're not telling you to simplify it, then you can leave it like that. If they do mention simplifying it though, this can be. Remember, I can take that 7/2 and I can rewrite it as 3 1/2. So this would be x to the third, x to the 1/2. So in its simplified form, if this had to be completely simplified, it would be negative 2x cubed and then the square root of x, or x to the 1/2. But you can leave it in the form if they don't mention anything about simplifying it. All right, next are going to be ones that do not look alike. So when I look at these two, they're not the same. So I'm going to start by transferring this into exponent form to see if I have to simplify anything. So 7 over the root, which is 3. Well, just by doing that, I ended up getting identical variables. So since these are identical, I can just add my coefficients and I get 10 m to the 7/3. Again, same thing. I can either choose to leave it like that unless they tell me to simplify it. And if they do, 7/3 is 2 1/3. So I would have m squared and m to the 1/3, which would be simplified to this, the cube root of m. So it just depends on what they're asking you. If they don't tell you how to simplify, you don't have to. You can just simply add or subtract your coefficients. All right, question F, we've done these. We've done square roots where we've had to simplify them to get them to be the same. Use your smaller one to help you. So I know I'm going to need a square root of 3. So square root of 12 divided by a square root of 3, square root of 4. I can simplify that. Square root of 4 I know is a 2. Multiply, 5 times 2 is 10. Radical 3, subtract the 19 radical 3 from it, you get negative 9 radical 3. Okay. So again, you might just need to utilize some skill sets of how to simplify it first. I'm going to move myself over here. There we go. So even with my bigger roots, do the same thing. Use your smaller one. Utilize that to help you out. I know there is no 5th root of 7, so I know that's not getting any smaller. So I'm going to divide 224 by 7, and I end up getting 32. Well, the 5th root of 32 is a perfect root. It is 2. So I can cancel that out. So now I have 2 5th root of 7 plus 3 5th root of 7. And that's going to combine to get 5 5th root of 7. And that would be my addition for that. Now, those are kind of basic, simple ones. They can get a little bit crazier, which we're going to see right now. So if we take a look at H, we are going to have to simplify both parts. Again, you can utilize each one to help you out, each side. I'm going to do one at a time. I'm just going to put a kind of a block here. Simplify one and then the other. Simplify as you normally do. I'm going to split everything into its own component so I can simplify it individually and easier. 4th root of 16, that is 2. The 4th root of w to the 10, I'm going to rewrite it as 10 over 4. which can be reduced. Mixed number is w squared to w to the 2/4. Again, don't reduce your fractions in this case because we don't want to change our radical. We want to keep them the same. So this side ends up becoming 2w squared and the 4th root of w squared on the inside. So I know this is going to be my goal. I better end up with that over here. 2w is not changing. I'm going to take my w6 over 4. I'm going to reduce that. That is w to the 1 and 2/4. So now when I combine things, whole values get to go outside. You multiply them together, so that becomes 2w squared. And then this guy goes back inside, 4th root of w squared. Now I can add them because these are identical. So 2w squared plus 2w squared equals 4w squared, 4th root of w squared. Now, this is acceptable. However, you may see, since it is only that single w on the inside, you may see that as 4w squared, square root of w, because there was nothing else. I didn't have to worry about another value inside with the radical. I could reduce it. All right, and our last question, I'm just going to pull that over. We got a lot happening here. I have rational exponents, and I got radicals. Got a lot. So we are going to start by combining and simplifying one side at a time, just like we did before. So these are both p's. I can add those exponents. So 1/2 plus 1/4. Well, 1/2 I can change to 2/4 plus 1/4 is 3/4. Okay, so this becomes p to the 3/4. Can't reduce that. There's no mixed number there. So that side is all done. P to the 3/4 minus. Over here, let's start simplifying that one. So we're looking at the 4th root of 16, and then the 4th root of p to the 3rd. Well, 4th root of 16, that is 2. 4th root of p to the 3rd, I can rewrite that as p to the 3/4. And, well, I already noticed I got a p to the 3/4 here. So I'm just going to keep them in fractional form because you want them identical. So either put them both in radicals or put them both in exponents. It doesn't matter. So if you wanted to, you could have the 4th root of p cubed minus 2 times the 4th root of p cubed. They're both identical, so it doesn't matter. And you're going to get -1 or just negative p, actually, to the 3/4, or negative 4th root of p cubed. Again, either option is fine. Since they gave it to you in both, there is no requirement to change it from one to the other. So one or the other. Okay, so hopefully that helps you out with your adding and subtracting, and you even got in a little review on how to simplify those radicals.